another boring title slide. However, I don't think I really need to jazz this up. I mean, it's hurricanes. Like, come on. Now, I know a lot of this will be preaching to the choir, as they say, because we live in hurricane country. We experience hurricanes. But let's get into a little bit more of the hurricanes. So, hurricanes are not called hurricanes everywhere in the world. That makes sense, right? And so the hurricane, where we call them hurricanes, is basically surrounding North America, right? The Pacific side and the Atlantic side. Those are hurricanes. Typhoons are over here, kind of over in Asia. And then cyclones basically fill up the entire southern hemisphere. So if it's in the southern hemisphere, it's a cyclone. If it's in the northern hemisphere, you have to decide if it's a hurricane or a typhoon. Now you'll see one part here. This ocean is usually too cold for hurricanes to form. And we'll talk about that, but hurricanes need to form in warm waters. That's not a warm water, so at least not warm enough. So it's not going to form here. So again, hurricane, typhoon, cyclone, not so much. Where do hurricanes form? Well, they have to form tropical to subtropical. Why? Because it has to be warm enough. There also has to be enough circulation or convective activity, right? Because hurricanes spin. Again, preaching to the choir, we don't need to know the hurricanes spin, right? But there has to be circulation in order to form that. Now, for it to be a hurricane, it has to have wind speeds of above 119 kilometers per hour. Again, we're doing science, so we usually talk in kilometers per hour. And there's not really a size for hurricanes. I mean, well, you watch hurricanes, right? You watch the track, and you watch the hurricane, and I mean, there's hurricanes that cover the entire state of Florida. And there's little hurricanes that do a lot of damage, and they're really small. Right? So they vary between 100 and 1,500 kilometers in diameter, so that means all the way across. Right? And again, tropical to subtropical. 5 to 30 degrees latitude. A couple reasons for that. Warmth is number one. Number two is your circulation. Right? Because at the equator, the Coriolis force, non-existent. Right? So you're not going to have your circulation. You're not going to get that spin. So it has to be just above the equator or just below the equator, and hence the tropical to subtropical. And you also have to have a steep pressure gradient. Now remember, we talked about everything wants to go from high to low. Right? So inside the hurricane, what do you think? It's a low. Right? And everything's rushing to the inside, but then again, it's getting deflected by the Coriolis force. Right? The eye. Right? The eye is calm, low pressure, very low pressure, and surrounded by rain bands. Right? And living in Florida, you might have experienced this, right? I moved to Florida in 2005. That's a good year for hurricanes, right? Katrina, Wilma, there's like 4 other ones that made landfall. It was crazy. My first year in Florida. Yay me. Anyway, we had a dog. When do you walk the dog? Well, not during the rain, during the eye of the hurricane. Right? So the hurricane came and hammered us. The eye comes. And when the eye comes, we all know it's calm. So we went out, we walked the dog, we went right back in, right? And like, do your business quick, let's go back inside, because we know the other side is coming for us. This is a nice one here, I forget. This is from, I think it's from one of the 2005 hurricanes. I think it's from Katrina. I'm not entirely sure anymore. I really need to go back and look at my pictures. Anyway, if you look at the speed, let's start with the red one with the speed, right? As the hurricane approaches, fast, 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 fast. Like it's good, right? You're talking 20, 30 knots, right? You're going quickly. And then as the center approaches, you start way up there, 60 knots, right? And then boom. Like between 10 and 0, right? Like, what? What just happened? That's a calm day. That's your eye. And then back up. As soon as the eye passes over, back up to like 50. And then as the hurricane goes away, you get the drop in the wind. Now look what also happens with the pressure. You start with 1,000, so not quite sea level, but still pretty good pressure. And then it starts to, as the hurricane approaches, it drops. You get here, where's this? This is the eye. Back up. Right? So everything's trying to get to that low pressure, that calm state. And of course we know that there's rain on both sides of the eye. Okay, so hurricanes, what fuels them? Well, latent heat. So that hidden heat we talked about way back when, that's coming into play. That heat of condensed water vapor is actually fueling the hurricane. It's keeping it nice and warm and keeping everything spinning. Right? Able to grow. Gotta take that out. Okay. This is why most are going to be formed in late summer to fall, right? Because when is the warmest months? It's not June or July, it's actually August. And water, what happens with water? Water takes longer to heat up, right? So it's got even a larger delay. And what's fueling hurricanes? The latent heat of water. Right? So you have that delay in the hurricane season, even though it's like, oh, well, if it's fueled by heat, it should be over here. It's like, well, yeah, but it's fueled by heat of the water, and the water takes longer. Right? This is where the warmest part of the earth is, the warmest time of the year of the earth. But with the water, it actually takes a little bit of time to catch up to us. So, hence the hurricane season. And now, the surface temperature has to be specifically 27 degrees Celsius or higher. Right? So if you do quick math on that, 27 doubled plus 32, right? So you're looking at about 86 degrees. So this temperature of the sea has to be about 86. Now that was quick and dirty because we doubled it and we didn't do the whole 1.8 or 9 over 5 or whatever, right? Just quick and dirty. But it gives you an idea. Okay, so how do they form? Well, it all starts, at least for us, I'm going to go with us because we get hurricanes and we want to know how our hurricanes form. So they all start in Africa. You start to get a nice thunderstorm. Right? And they're just like, whoa, thunderstorm, whatever. And you're like, thank you so much, Africa. I don't like your thunderstorms. Because if they start to get a thunderstorm and that thunderstorm is high enough where it gets caught in what they call the African Easterly Jet, the AEJ, it can start to spin. And of course, if it starts to spin, what happens, right? As long as that spin is still there, as long as that heat is still there, it's still feeding it. It's feeding it and it's allowing it to spin. If something comes and like just swipes off the top, like if it's straight wind, just right through, then it's going to basically cut it and that's it. Like it shears it off, as they say. But if that spin gets to stay, and if the water is warm enough, you start to get the hurricane formation. So it all starts with clouds or thunderstorms over in Africa. And they have to be able to grow. They have to be able to get offshore in the easterly jet. And the easterly jet causes them to start spinning. Now, what else has to happen? Because if it comes into low pressure or a high pressure system, well, you need to have the pressure drop, right? You need to be a low pressure. It needs to stay low pressure. If that pressure gets filled in, and a high pressure is like, oh, and I'm just going to fill in the low pressure, well, then done, right? So you need to keep that low pressure center. How is that low pressure created? Well, down here, you have to have an area of low pressure, and that has to be strengthening the low pressure or weakening the pressure, however you want to think about that. But basically the pressure has to continue to drop. Up here you want the high pressure so that it continues to flow out. Right, so it's flowing in here, out here. If it stops flowing out, it's just going to fill it all up. So you need to make sure that it's flowing out and in, out and in. Now, assuming that the pressure stays good, i.e. Low pressure system in the middle, high pressure at the top, so everything's flowing out, it's not infilling, that it doesn't get sheared, right? So it keeps its rotation. And the warm water, so it stays over top of warm water, then it can develop into different things. And we all know these different things, right? The first one is a depression. So here's a depression. And you can see it's kind of organized. It's got a nice little tail here, but it's pretty organized there. And for a depression, it has to be developing, right? It has to have that low pressure, it has to have the circulation, again, over warm waters. But it can't be too strong. If it's too strong, we change it. So what is too strong? That depends on the wind speed. The wind speed can't reach 63 kilometers per hour. Because once it reaches 63, we say, okay, now it is a tropical storm. And so here's Isaac, tropical storm. And with the tropical, wait, this is tropical depression 12, this is tropical storm Isaac. Yeah, once it hits that storm, once it hits 23 kilometers per hour, it's now named, right? It's given a name. And we'll go over these names. But some of them get retired. For example, Hurricane Sandy, Hurricane Katrina, Hurricane Irene, Hurricane Andrew. Those are all retired. They happened. They caused a lot of devastation. And so we don't want to have another hurricane. Let's just pick on Katrina. Right? Katrina caused a whole lot of devastation. And so if we rename another one Katrina, well, then if that one causes some devastation, you know, we'll have some person in the future going, well, I survived Hurricane Katrina. And you're like, oh my goodness, that was devastating. They're like, yeah, I know. And then, but they mean Hurricane Katrina 2026, not Hurricane Katrina 2005. Right? And so you don't want to get that confusion going. So they retire a name. And here's the names. 2020, 2021, 2022, 2023, 2024, 2025. If you're watching this in 2026, I'm sorry. Look at the new PowerPoint. I'll have updated it. But we all know these. We went through all of these. Now, we didn't go through all of these. Like, they didn't all make landfall. But all of those have been used. Right? And what happens when they all get used? They go to the Greek alphabet. Alpha, beta, delta, eta. I don't even know the Greek alphabet. So they go into the Greek alphabet. I have to look it up every time to be like, oh, what's the next letter, right? And then here you have, well, why do I have 6 years here? 1, 2, 3, 4, 5, 6. Because that's how they name them. They go through a 6-year cycle. So in 2026, if you are watching this and I haven't updated it, they're just going to use 2020 again. Unless one of them got retired. I don't think any of these did. But if one of them gets retired, then they won't use it again. Like, let's just, again, pick on Katrina. We got Kyle, Kate, Carl, Katya, Kurt, and Karen. Huh. No Katrina. No, because that one's taken off. If you look at the for Irene, nope, 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 nope. Right? So any of the ones that get retired will never appear on these again. They'll replace them with something else. They'll come up with another name. The other thing you should notice, and again, you probably know this, but it goes boy, girl, boy, girl, boy, girl. Right? Arthur, Bertha, Cristobal, Dolly, boy, girl, boy, girl, boy, girl, right? And then it ends on a boy, so the next one is going to be a girl. Ends on a girl, next one's going to be a boy. Okay? And they continue this cycle. What makes a hurricane die? Well, you probably already know this, right? Land. Land is a really good one to make it die. Why? Because, well, land doesn't have that latent heat of water. Land has friction. So land is really bad for hurricanes. Right? Latent heat cutoff moves over land. We get the whole land part. Or it could move over colder waters. Right? It could move off into here and start heading off to England. If that's happened, and it starts to weaken. So by the time it gets to England, it's either a depression or a thunderstorm, like if it makes it all the way up there, because it's too cold up there for the waters. Could happen that something happens up top here, aloft is how they say that, up top, and a wind comes and shears off the top. Well, you chop your head off, what are you going to do, right? It's going down. That happens a lot more down in here than up in here. Okay, so it happens a lot more down as it's coming towards us. Is that shear going to take over or not? Alright. To determining how do we rate these according to destruction? Right, because if you look at tornadoes, right, if they hit Timbuktu or the middle of nowhere and they blast down a couple trees, meh, who really cares, right? If they hit, LA on Sharknado, lots of destruction, everyone's like, right? But they could both be F4s and they're both F4s. Like, that doesn't really matter. They could both do destruction, but they're both the same strength. When it comes to hurricane, because they're so large and cover such a big area, the only thing that determines its destruction is its strength. That is the only thing. How strong is it? Is it a Cat 2? Is it a Cat 5? Right? Just by saying Cat 2 and Cat 5, there's a little bit of anxiety that comes with the words Cat 5. Okay? There's a little bit of anxiety that comes with the word Cat 4. Cat 2, you're like, okay. We gotta hunker down a little bit. It's Cat 2, right? I mean, Cat 1, we're just like, yeah, whatever, it's a storm. But strength, we know those terms. You say Cat 4 hurricane, people start to panic. And so they should. So if you look at the deadliest hurricanes until 2011, I'm probably going to have to update this sooner rather than later. Texas, 1990, Category 4, 8,000 deaths. Southeastern Florida, Lake Okeechobee, 1928, Cat 4, 3,000 deaths. Katrina, 2005, Cat 4, almost 2,000 deaths. Audrey, 1957, Cat 4, 400. Florida Keys, 1835, Cat 5, 400. Florida, Alabama, Mississippi, Florida, 1926, Cat 4, 400. Louisiana, 1909, 350. Florida Keys, South Texas, 1919, 300. Louisiana, 1915, 300. Texas, 1915 again, 300 again. Wait a second. Texas, Florida, Katrina, Audrey. Florida, Louisiana, Texas. Huh? How come, where's the names? They didn't start naming them until the 50s. So these guys didn't even have names yet. Another thing to notice is a lot of the ones that caused deaths were really early on, before they had things like radar and airplanes that could fly into them, and satellite. Katrina was interesting because it wasn't the actual hurricane that caused all these deaths. It was that the hurricane broke the levee, and then all that water flooded Katrina and caused all those deaths. So it wasn't the hurricane itself, it was that the levee wasn't taken care of and broke. How do we rank these? Saffir-Simpson scales. That's how we rank them. Okay? I don't think I told you. Oh, no, I did tell you on the first one. In order to become a hurricane, you had to have 119 kilometers per hour. Alright. So the Saffir-Simpson scale ranks the intensities of hurricanes, but not just on wind, also on pressure. And it also tells you about the storm surge. That's interesting. Storm surge. And the rank also means if it were to make landfall right now, this is the type of destruction it would cause, right? Because the only thing that matters for destruction is strength. Cat 1, greater than 980 millibars. Now what's sea level? 1013. Winds 119 to 153. Storm surge 1.5 meters. That's about 5 feet. So I'm not the tallest. Yeah, I would be mostly underwater. I'm 5'4". Yeah, okay. This is why I live inland. Cat 2, and lower pressure, higher winds, 2.5 meters-ish. Right? Damage minimal, moderate. Cat 3, pressure at about 950-ish, winds at 200, 3 meters of storm surge, extensive. Cat 4, 930-ish, let's go 225, 4 plus, extreme. Cat 5, less than 920, bigger than, just bigger, right? Just bigger. Catastrophic. Okay, in case you're wondering, there's miles per hour, there's feet for you, millibars,